Hello and welcome to hACkathon on Pixel Lake Festival Radio. I'll be your host, Justin Tyler Tate. In addition to this audio program, accompanying visual material can be found at the companion website http://hackyourac.weebly.com. We all know that carbon accumulating in our atmosphere is a growing problem, causing the warming of the planet, the acidification of the oceans, and a justifiable unpleasantness in teenagers. Sure, we could blame the governments and corporations for being the biggest contributors to this problem, but as they're unlikely to change anything, let's crowdsource our abilities, know-how, and resources to hack together a solution. It's fair to say that air conditioning systems are a pretty big contributor to greenhouse gases. They use a lot of electricity, and as the planet grows hotter, people want to use more air conditioning. It's not so much a vicious cycle as much as it is a downward spiral. But imagine if they could be used to solve the problem, or at the very least to mitigate the harm that they're causing. It's not as far-fetched as you might think. In this episode of hACkathon, we're going to try to modify an air conditioning unit to become a carbon capture device. You can follow along at home or try to develop your own methods based on what you learn during this radio program. When we talk about carbon in the atmosphere, perhaps you might think this is something unprecedented, which is kind of true because this time it's been caused by humans. But actually it's happened before. Very long, even older than your grandmother a long time ago, about 3 million years ago was the last time in Earth's history that the carbon in the atmosphere was higher than it is today. And if I can just set the stage for you, it was during the Pliocene epoch, and at that time forests extended all the way to the Arctic, and strange mammals such as the Smilodon, the saber-toothed tiger, Megatherium, the giant sloth, and Glyptodon, a giant armored armadillo, roamed the earth, as well as a slew of large flightless terror birds. And the seas hosted Megalodon, the largest shark that ever lived. And that was just the last time. There was a time even before that, 2.5 billion with a B, years ago, when there was no trees or other plants, and all the life lived in the seas. And it was all bacteria, and none of it used oxygen. And that was because there simply wasn't enough oxygen. So the question I expect you to have right now is, but Justin, where did all the oxygen come from? And the simple answer is algae, cyanobacteria, to be specific, drank up all of the carbon and burped out all of the oxygen. It made it possible for the world to host complex life then, and it can help us fix the mess we've caused now. We can use other kinds of oxygen-producing algae also. Algae comes in many different colors, and it can be found in all kinds of places. Perhaps you have some growing under your toenails right now. I, of course, cannot speak for your personal hygiene. And not to sound like too much of a fanboy, but algae is something like magic. Some varieties can provide you with all your daily nutrition. You can use them to produce biofuel. You can turn them into vegetable oil. Other varieties produce omega-3 fatty acids. You can use them as high-quality compost. And they're the foundation of the aquatic food chain. And they're just a single-celled organism. What have you done today that's so great? Nothing. That's what. It should be quite clear that under normal circumstances, you wouldn't want your air conditioning unit to produce green slime. But unusual problems call for unusual solutions. So what we're going to do in this episode of hACkathon is to modify our air conditioners so that the hot air that gets pumped out as waste into the world feeds our algae photobioreactor. All air conditioners work in essentially the same way. They absorb the heat from one space and use a liquid to transfer that heat to a different space where they blow it away by use of a fan. Some air conditioners mount in your window, some on your wall near the ceiling and have a tube that goes outside. Others have one part on the inside of the house while the other part is on the outside, but they all use the same basic method. A large portion of the air conditioner's functionality isn't really all that important to us. All we need is the exhaust. What we want to do is capture the exhaust, focus it so that it pushes through an algae solution, and let the algae extract the carbon for us. The algae are going to do all the work, but we need to give them a proper environment where they can thrive. In addition to the carbon in the air, they also need sunlight because photosynthesis. Luckily for us, we can take advantage of the fact that air conditioners' exhaust needs to be on the outside, and hopefully it is also in a relatively sunny location. Many large buildings and businesses have huge air conditioning units on the roof, which, if possible, would be ideal to modify for your algae photobioreactor. Depending on where your air conditioner is located, will also give you a reason to consider the final use of your algae. For example, it's great if you're located near a heavily trafficked road because there will be a higher concentration of carbon in the air there. But there will also be pollutants that you may not want to ingest, and it might be better suited for fertilizer, throwing into the sea as a tribute to the gods, or turning into oil and biogas. If you live in the countryside, however, then your air conditioner turned carbon capture device won't have as much carbon to suck up, but it also won't have many other pollutants, so the final product would be well suited to using as a nutritional supplement. Ultimately, you will have to make a decision for the final use of your algae, because half of it will have to be removed every week or two to allow for more to grow, suck up carbon, photosynthesize, and reproduce. You could think of your hacked air conditioner as a pet, but it'll be less work than a dog or a cat, but more work than a pet rock. And instead of making waste, it cleans up our waste and could potentially provide you with all your nutritional needs. Now, what we're going to need for this project is some simple things that you can find around the house, in your recycling bin, from your local hardware store, and in a nearby pond. First, we need a container that fits nicely over the exhaust of your air conditioning unit. This is probably going to be the most difficult thing for you to find, but you could also make it from scratch. You'll probably want it to be made out of plastic or wood so that you can easily drill through it, but other materials could also work. Use your imagination, that is what it's there for. This container is going to trap the exhaust air and force it through a series of tubes in parallel. That's what we're going to need next. A whole bunch of tubes. The clear vinyl ones which get used in aquariums. How many and how long the tubes should be will also depend on your air conditioner and your vinyl design. You'll also need a drill and a drill bit that exactly matches the diameter of the tube. You'll need a lot of bottles with matching caps. Plastic or glass would both work, but plastic will break down over time because of exposure to sunlight. It's also important to use distilled water or tap water so long as it does not have any chlorine or it's been sitting out for a few days in your final setup. Lastly, and most importantly, you'll need a sample of viable algae. You can order a live sample online if you're looking for a specific variety. Spirulina, which is a kind of cyanobacteria comprising 3 species within the genus of Arthospira, is known to be super healthy and contains all of your daily nutritional needs. If you want to use algae for your own nutritional benefit, then your best option is to order and grow some spirulina. If you want it just for about any other purpose. You can gather some algae from a nearby pond or river, a friend's aquarium or hot tub, that glass of water that you forgot on the windowsill a week ago, or a myriad of other places where algae naturally develops. Other things you'll need are silicone caulking, plant food with nitrogen and phosphorus, something like wire or zip ties that you can tie things together with, and a knife. Just to reiterate before I move on, I'll be describing all of the directions on how to build your passive parasitic carbon capture photobioreactor in great detail. But if you need more visual information, such as images or text, please visit the accompanying website, http://hackyourac.weebly.com. Just a note before we begin modifying our air conditioning units. You shouldn't have to open it up, but depending on your air conditioner, you may want to screw something together or duct tape a hose to something. I don't know, anything could happen. But if you need to open up your air conditioner, if you absolutely need to, please first unplug it. They can give you a nasty shock if they're plugged in, and if you're poking around inside of them, actually, even if they are unplugged, they can still give you a nasty shock if you touch the wrong part. So please be careful. So, with my air conditioner, I'm going to start by making a rigid wooden pyramid to cover the air conditioner's exhaust. This is going to allow me to capture the exhaust and funnel it into the bioreactor. I need to make my cover so that it doesn't obstruct the unit's intake because we need the intake to suck in carbon in the form of air. I chose to use wood because it's readily available, easy to repurpose and finish, and I'm also just used to working with wood. You can also choose wood, but if you're not that familiar with woodworking, perhaps you'd prefer to choose something you have the tools and experience to work with. Or maybe just find and repurpose something that fits onto your air conditioner. Maybe plastic works best for you, or steel, rubber, carbon fiber, etc. If you do decide on using wood or steel, you'll have to finish it so that it'll be protected from the rain with a varnish or paint for exterior use. Whatever material you choose, a lot of pressure from the exhaust will build up on the inside of the cover before it's able to escape out the sides and through the tubes. You'll most likely have to support the weight of the algae water bottles, and it will have to survive through inclement weather. So your cover will have to be quite sturdy. Remember, you are the architect of your own carbon capture device. Now that we've got our covers constructed, we're going to need to plan where our bottles will be placed. To plan this, we'll also need to consider that the bottles will need to be capped so that the cap is facing upwards and can be attached directly to your cover or to the sides of your air conditioner, or, well, this all depends on your particular air conditioning setup. So it'll be for you to figure out how not to make a slimy green mess all over the place. In my personal plan, because my air conditioner exhaust is a big vertical box, I'm going to mount the bottles evenly across the air conditioner cover and also down the sides of the unit. This is going to give me plenty of surface area to grow algae, as well as a lot of potential to capture carbon. Because the pyramidal cover I built has a flat top, I'm going to drill most of the holes for the tubes there, evenly distributed. This is where the majority of the air will flow to. On the sides, I'll also drill some holes for tubes, but I'll make sure not to drill so many because I'll need space for the bottles, and they'll also become less efficient as they reach the bottom opening of the cover. You'll also want to drill them so that the vinyl tubes will fit quite snugly, because you don't want them to pop out, and also because we want the air to flow through the tubes and not out any gaps. Have you drilled your holes yet? No one is going to drill your holes, and I'm not going to wait for you, so you better get to it. Now with all of your holes drilled, insert one end of the vinyl tube into them and use the silicone to seal the connection between the tubes and the cover. If you're going to attach the bottles to the cover, now would be the time to do that. You can potentially use some sort of pipe clamp, wire, or zip ties. This step depends on a lot of factors, including how you want to arrange your bottles, where they'll be, what the material your cover is constructed out of, and so on. You can also have your bottles separate from your cover and mount them as a kind of solar panel, but in that case, you'll need more vinyl tubing to account for the space between your air conditioner and the bottles. This step is up to you and what your situation is like, so I'm going to have to trust you know what you're doing, more or less. With your bottles mounted and your cover in place, you'll need to drill 2 holes in each bottle top. One hole needs to be the exact same size as your vinyl tubing. The other can be the same size or a bit smaller in an attempt to prevent evaporation and allow for some pressure to build up inside the bottle. At all stages in your carbon capturing bioreactor, you need to remember that you're using an air conditioner as an air pump. But unlike normal air pumps, if too much pressure builds up, then it will stop moving through the air conditioner and thus stop cooling efficiently. So you will need to find that point of equilibrium where enough air is flowing through your system and into your bottles, but not too much air is being stuck in the cover you constructed. If too much air is getting stuck behind your cover, you can alleviate the pressure by drilling more holes around the base of your cover or adding a bit of space between the cover and the air conditioner so that air can flow at the bottom. You don't need a lot of air bubbles flowing into each bottle, but you definitely need some. Anyway, with your holes drilled in your bottle tops, you can now insert the tubes into the holes, so about 15 to 20 centimeters comes out of the bottom. You want for the end of each tube to be near the bottom of the bottle, but not touching the bottom. Your carbon capturing bioreactor is looking pretty good right now. Just a couple more steps and we'll be finished with the project. And then you can make 100 more to compensate for all the all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun that you've eaten in your life, if you know what I mean. Next, you'll want to prepare your algae samples. You did acquire them, right? I hope you didn't forget, because they are the most important part of this whole project. I'll just wait for you to dig them out. So now that you have your algae samples in hand, you'll need to evenly distribute them among your bottles. You should pre-mix your chlorine-free water with the plant food, high in nitrogen and phosphorus, in one container, so that every bottle will contain the same amount of nutrients for your algae. Now fill up each bottle with the water and plant food mixture until 3 to 5 centimeters below the top. Cover them and make sure they are all secure. Cover your air conditioner if it's not already. If you've followed all the steps correctly, then your algae bioreactor should be bubbling away. If it's not, then you're going to have to troubleshoot where the problem is in your system. Is your air conditioner on? Is the cover installed correctly? Are there 2 holes drilled into each of the bottle tops? Is one end of the tubes inserted into the air conditioner cover, with the other end inserted into the bottles? Is there enough pressure building up inside of the cover? Is there something obstructing the tubes? These are the questions you'll have to answer before you can have a fully functional, passive, parasitic, carbon-capturing photobioreactor. Figure it out. Your device will capture carbon in direct proportion to how much algae you have bubbling away and how much sunlight it receives. When your bottles become a dense-looking green slime and algae begins to clump and sink to the bottom, it's time to remove half to 3/4 of the bottle's contents and top it up with more water and plant food. You can filter what you've collected through a fine mesh strainer, cheesecloth, or French press to filter out some of the water. You can then dry it in the sun or turn it into a powder which can be used in any number of recipes as additional flavoring or as a nutritional supplement or as a source of an unsettling green color. You can also turn your strained algae into compost, vegetable oil, or biofuel. The possibilities are only limited by your imagination and, of course, physics. And there you have it, your own working, passive, parasitic, carbon capture photobioreactor. Only 2 people listening to this blew up their air conditioner in the process of hacking it. One person was shocked because they opened the air conditioner without unplugging it. And 7 people cut themselves while trimming the vinyl tubes. All things considered, seems like a very successful day to me. If you need to recap anything or see visual examples of what I've described during this program, then please visit http://hackyourac.weebly.com. Also, though I've only described the process for hacking air conditioning units during this program, there are likely to be other appliances which you can modify with the similar process, or you can just build the photobioreactor portion of the project and hook it up to an air pump powered by some batteries and some solar panels. I've also imagined the possibilities of using old fluorescent tubes to make a photobioreactor, which could be quite aesthetic as well as functional. It is ultimately up to you how this process could be modified to suit your needs. I've based my research on pre-existing open source research, which in turn was research based on other people's work. As with most things, we continue what others have started, in the hopes that others will continue from our contributions. One person making a passive parasitic carbon capture photobioreactor will do little to alleviate the oversaturation of carbon in the atmosphere and human-caused global warming. But if we work collectively and crowdsource our actions, then perhaps we have a chance at not dying on a scorched earth with occasional flooding and a mass extinction to compete with all previous mass extinction events. As I said before, this problem is not caused by most of us, and many of us do little to exacerbate it. But that doesn't mean we're still not responsible to find solutions for it. If we wait for others to fix this problem for us, then we'll probably be waiting until we're no longer around to notice that the problem still exists. We also have to remember that this is a band-aid solution. It doesn't fix the root cause of the issue, which needs to be addressed through collective buying power, and as in not buying things which contribute to greenhouse gas emissions, such as beef and dairy, while simultaneously using our resources towards products which promote sustainable change, such as renewable energy, public transportation, etc. As I see it, it's all a lifestyle choice. We can either choose to have a life by trying to fix the problem through developing innovative solutions together, or eventually all die in some natural and preventable catastrophe. Anyway, thanks for listening to this radio play, podcast or workshop or whatever it's been. Thanks for sticking it out until the end. It hasn't always been fun and it hasn't always been informative, but hopefully it has still been enjoyable. At least more enjoyable than cleaning the algae out from under your toenails. Maybe you've learned something along the way that you'll be able to utilize as you make your passive parasitic carbon capture photobioreactor, but it's my hope that you can also use what you've learned in your life. Until next time, this has been Justin Tyler Tate, and you've been listening to hACkathon.